In this segment, we're going to talk about counting and matching. And we're going to use the human calculator, our fingers, in order to demonstrate that process. Now, we have used this many, many times. Whenever we count, we make a match between each finger and whatever object we're talking about. On my table here, I have some objects which are dominoes. And let's make a match between each of my fingers and the dominoes. Here we have a collection of 5 objects, and I can do the same thing with my other hand and get another collection of 5 objects. One thing that math does for us is it makes order out of chaos, as we can do right here, and place these on the number line. It's clear why this is called a number line, since it has the numbers on it. And you can see we have the numeral 10 as we move from the left to the right. And we can count the objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a matching with our fingers by using the human calculator. This is a common thing that we do almost all the time. When we're in the supermarket, in our basket, we often count the items. 1, 2, and so forth. Mathematics in everyday life, simple and understandable. Yeah, I've always thought of addition as counting, and I've used a tool to explain why that's so. And the tool that I've used is a domino. We see over here we have 5 dots, and what we're going to do is form an addition problem by adding on 5, 6, 7, 8. So you see we've created the problem 5 plus 3 equals 8.
And when I look at the domino and I'm thinking of addition, I'm thinking of combining or putting them together. Now, probably I can show that better on these chairs back here. This group of 3 chairs came from one room. This group of 4 chairs came from another room. If I put them together, I know that I can seat 7 people. Or I could even think of this as 30 chairs, 40 chairs, and I can seat 70 people. That's the power of that little addition fact.
3 plus 4 is 7, so 300 plus 400 would be 700. The simple fact leads to some powerful mathematics, or arithmetic, if we'd like to call it that. I've also used a number line to show that. So let's go over to the number line and take a look at how we might look at your groups of chairs as groups of other things. You know, the numbers that we use always stand for groups of things. And here, let's say that these 4 cubes are like the 4 chairs that you had, and these 3 cubes are like the 3 chairs that you had. And if we put them together, as you said, by combining, we slide them up here, we see that our result is 7. In other words, 4 plus 3 is equal to 7.
Aha, and I have another item to talk about here with addition. We could also have thought of this as the 3 chairs first, and then adding the 4 chairs, and we would see that 3 plus 4 also equals 7.
So the order that we add in, whether we add the 3 to the 4 or we add 4 to 3, gives us the same result. That's an important thing for addition. You know, the number line also shows us one other property that addition has, the property of 0. If I take these 7 cubes and I put them in there, and then I add 0 cubes to it, it's obvious that I have 7 left. And that's the property of 0, and that's how I show that.
And I have a good example of the property of 0, Vince. The other day when we were pulling the materials together for the barbecue, and I had 4 packages of hot dogs in the refrigerator. One of the couples came in and had another 2 packages of hot dogs, but the third couple came in and they didn't have any. Altogether, I had 2 plus 4, which is 6, and 0 added to that, I still had 6. Again.
That's a good example of how we use 0 in addition, and it kept the number the same. So, you know, in review, what we've looked at is that I look at addition in one way by adding on or counting on. Here we have 4, and then 5, 6, 7 gave us the 4 plus 3, which was equal to 7.
And I look at that same addition as taking a group of 4 and a group of 3 and putting them together to get my 7.
We also looked at the fact whether we added 4 plus 3 or 3 plus 4, that would not affect the result. Order of the numbers in which we add is not going to change our result. It's an important property for addition. We also looked at, of course, the 0 property, the example that you gave, adding the 0 hot dogs.
And also the power of the simple number fact. Let's not forget that as we're reviewing. That 3 plus 4 can also lead to 30 plus 40, 300 plus 400.
Or any number fact does that. 5 plus 7 we know is 12, so 500 plus 700 is 1200. There's real power to knowing basic facts.
Let's take a look at reading some large numbers. Here's a road sign, a population sign. How do we read it? Well, we know that's 227, and the comma tells us the next number is the thousands place. So that population is 19,227. Here's another sign. This is an elevation sign. It tells us how high some mountain peak is. What's this number? Once again, using the comma, we read it as 12,432. So we can read large numbers. Let's look how we understand large numbers. I was reading a newspaper today, and there was an article in here. It says that some town has a population of 1 million. Do I really believe that that city's population is exactly 1 million? Absolutely not. It's very possible the population of that town is 995,500. And they rounded off, or estimated the population at 1 million. Well, why would they do that? They would do that because 1 million is a round number. What does that mean? A round number is a number with a bunch of zeros in it. Well, why would they use a round number? For two reasons. First of all, 1 million is fairly close to 995,500, and therefore is a good representation. But more importantly, 1 million as a round number is easy to read and is easy to understand. Let's take a look at 1 million. Here it is written out. It's easy to read because of the commas. Notice, if the commas weren't there, it wouldn't be very easy to read at all. Let's examine once again what the commas tell us. This first comma separates the thousands place from the hundreds place. The second comma separates the millions place from the 100,000s place. Seeing the two commas and the one in front lets me know that that is 1 million. 1 million is a rather large number. You may ask, how large is 1 million? Let me give you an example. What do you think $1 million in $1 bills weighs? It weighs over a ton. So not only is $1 million a lot of money, it's a lot of paper. What if another headline told me that 10 million people had visited some national park? What would that 10 million look like? Well, once again, the commas would be there, and we have a 10 in front of the second comma, telling us that 10 million, thus making the number very easy to read. What have we seen today? We've seen that using commas, it's very simple to read large numbers. More importantly, we've seen that large numbers, especially round large numbers, are not only easy to read, but also very useful. In fact, look around your world and see how many large numbers you confront every day.
Every day in my business, I use a number line or measuring tape and a pencil at least 100 times. Making all the right cuts the first time, you don't have to do them again, you don't waste material, and you don't cost yourself money.
There's a legend that the game of chess was invented for a great king who was so pleased with the game that he offered to give the inventor anything he wanted. The inventor's request seemed modest at first. All he asked for was 1 grain of wheat to put on the first square of the chessboard, 2 on the second, 4 on the third, 8 on the fourth, and so on until all of the 64 squares of the board should have been allotted the right number of grains of wheat. It doesn't seem like much, doubling each time, but in fact the total number of grains of wheat necessary is 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709,551,615 grains exactly. That's more wheat than there is on the whole world. As a matter of fact, that many grains of wheat would cover the entire surface of the earth with wheat several inches deep. I wonder what happened to the inventor.
Putting mats on a piece of artwork is obviously a problem of addition. First thing you need to do is figure out how big the opening is going to be, how large a space you want to have, and this looks like about 13.5 by 8. So if we take 13.5 by 8, and decide, oh, probably about 2 inches of mat would be nice for a piece this size, we'd be ending up with something in the neighborhood of 12 by 17.5. And the way you do that is you're going to need about 2 inches on each side, so you come up with a total of 4, 2 and 2, plus the opening that you have, and 2 and 2 plus the opening in the height. So 12 by 17.5 is your total size. And then go back and split that in half again, so that you get the same result in the end as you do while you're planning. It's something I learned from an old carpenter friend of mine. Told me to measure twice and cut once. So we check and make sure that our dimensions are going to turn out well. And then we just cut it. Now, if we've done our addition right, we should end up with something that looks like that.